So hello everybody and welcome to my talk. Today I want to talk about a feature of C++20, and I personally consider C++20 as a great iteration of the language with a lot of cool features. There are some smaller features, but also a lot of bigger features which make C++20 really cool. And I think it's impossible to rank all these features in terms of importance. And I think it's also impossible to talk about all of them in depth in a single talk, unless I had like 5, 6, or 7 hours, and this is way too much. So I will talk about only one C++20 feature today, which is modules. And this talk is a practical introduction to modules. So we will learn how to write modules, handle includes together with modules, how modules work, and much more. And for me, practical means that I will show you examples which work today and can be compiled today, at least in a single compiler. And this will be for this talk, Visual Studio. So I talked about code and slides already. So if you want to follow along, here is the link to the slides and also the demo code, which is a Visual Studio solution. You can already download that if you want to follow along or want to try out things after the talk or have a look at the slides. If you don't want to type the link right now, in the top right corner, you see a QR code, which you could photograph, for example, with your smartphone to get to the link as well. I will leave the slide on for like 5 or 10 seconds so that you can type or photograph if you want. So I also don't want to talk much about me. Here on the slides, you find the things I like to talk about professionally. If you want to chat with me about programming related stuff at the conference. And I also would like to ask you to ask a lot of questions and give feedback to this talk. We will have time for Q&A in the end of the talk. So I will talk for roughly 60 minutes, and then we have 30 minutes of Q&A. And you can use here the Q&A settings of the Zoom webinar. And if you want to reference your questions to certain slides, the slide number is in the bottom right corner. So right now we are at slide number 4. Okay, somebody complains about sound, but for the rest of the participants, the sound seems to be okay. So I will just continue. Yeah. Also, if you watch this talk after the conference is over, or if you don't want to post your questions here in the Q&A system, you can also send me questions and feedback to this talk on your favorite channel after the conference is over. And here you find all my social media contacts if you want to use them, for example, like Twitter or LinkedIn. Before we talk about modules in C++, let's talk a little bit about the meaning of the word module in general for software engineering. So from the perspective of software architectures, modules fulfill the purpose of information hiding. So the user of our module does not need to know what happens inside of the module. Encapsulation, so only parts of the module are exposed to the user. And interchangeability of parts of software without changing interfaces. So the hidden and encapsulated content of the module can change without affecting the user, and the user has only an public interface which they need to work against. And the user does not need to care about implementation details of a module which might change without the user knowing. For me, one important thing is also that a module and a package are different things. So modules are used for interchangeability within a program. So our program consists of several modules, and packages serve as a format for the distribution of libraries. So exchangeability to the outside. For example, I can use Conan and VC package to download new packages for using inside of my program. And of course, packages can consist of or the libraries I download with the package manager can be modularized. But a module is not a package. And unfortunately, some programming languages like Dart, for example, call their modules or their module system packages. And this is really unfortunate. Although C++ before C++20 has no modules, we do modular programming in C++ all the time. And we can consider separate CPP and header files as our modules. The header files declare our interfaces and the CPP files are our implementations. And we can use tools like anonymous namespaces for hiding information from the user. And this is perfectly well-defined modular programming from an architectural perspective. But this way has some downsides. So include directives are used by the preprocessor for doing copy and paste. So the same code will be copied into our files over and over again, and then it will be compiled all over and over again by the compiler. And in the end, the linker will throw away a lot of duplicate stuff. And this can, for example, lead to huge compile times if templates are involved. Also, macros are not private if they are declared in a header. So all macros are available after an include. And this can also lead to problems, as we all know. And one thing which is also unfortunate, that the order of includes can be important in a project and can lead to problems which are hard to diagnose. And all these problems are not special to C++. They are somehow tied to the preprocessor, and the preprocessor is a legacy we inherited from C. And modules will at least make some of these problems go away right now, and maybe even more of these problems in the future. Now, when I talk about a new feature of C++, I think it's also important that we talk about which compilers support this feature already. And at the moment, the best compiler and build system with modules support is Visual Studio. So if you have Visual Studio 16.8 or the newest version 16.9, you can do all the things I will show you. And the support in GCC and Clang in the newest version is less than in Visual Studio. So it's partial support of what we can do now with Visual Studio. One interesting thing about modules is that they are a C++ language feature which are not only dependent on compiler support, but also dependent on the support of the build system you use, if you use a build system in your project. Because the build system has to look into our CPP files to understand modules, or they need to have a feature to explicitly tell the build system, or the build system itself needs to have a feature to explicitly tell it the dependency graph of our modules. And this is a little bit scary, and I don't know from the top of my head any other C++ language feature which such a heavy dependency on the build system. The overall build system support at the moment is a little bit grim, unfortunately. Visual Studio with MS Build has the best support at the moment. There's also Build 2, which works well with the GCC compiler and modules. And there's also the Meson build system, which in its newest version, which should be 0.57, features experimental support for modules with the Visual Studio compiler. And you are not tied to a build system. You are, of course, free to write make files or batch scripts for compilation with the correct compiler flags for modules. But if you are in a project which uses a build system, you need to know, or you need to find out whether your build system supports modules already. So this talk features exclusively a Visual Studio example. And therefore, I don't want to talk much about other compilers. But if you want to try out modules with GCC, there is a great blog post which came out recently about setting up build 2 and GCC trunk for using modules. And you need for both GCC and build 2 the newest versions. This might be high effort for you to get that working, or it may be not dependent. It depends on you. And a lot of stuff like modules, a lot of stuff from the modules feature set already works in there. So you can try that out if you want to use GCC. CMake is usually the most popular meta build system we have for C++. And therefore, I have to talk a little bit about CMake module support. And unfortunately, at the moment, there is no official support for C++ modules yet. And it seems that it will not be there quickly. And this is unfortunate since many people use CMake. So there are, if you look on GitHub, some projects which try to add experimental support for modules to CMake, but they are not tied to the official CMake developers. They are add-ons. They are sometimes also fixed to compiler versions of GCC and Clang, and some of them are also out of date. So as of now, I would not recommend trying to use modules in the CMake-based projects. And now I want to switch to actual code in Visual Studio. So we will write some modularized code and look at some modularized code in Visual Studio. Again, if you have the link from the second slide, you can now load this solution into Visual Studio if you want to follow along, if you haven't done that already. And we will brush over some features of modules here and talk about them in depth in the upcoming slides. Okay, now you all should be able to see my Visual Studio. And if you think the font size is too small, please write that into the chat. Okay. If nobody is complaining about the font size, I can start. So let's first talk about how we get a Visual Studio project to support modules. So we need a fairly new version of Visual Studio, so at least 16.8. And then under the project properties of our project, we have to go to C++ language, and then switch it to previews feature from the latest C++ working draft, so stood C++ latest. And this is the only thing we need to change to get modules support. If we have done that, we can add modules to our code. And this works similarly to adding new code. To our project, we can add a new item. And what we see here is the usual CPP file, the usual header file, the usual class. And what's new is a C++ module interface unit. And if we add one of these, it tells the compiler and the build system that we here have a module which needs to be taken care of. I've already added some of them, and nothing special happens if we add a new one, it's just a new file, and build systems dependencies are updated. So let's look here at this file, numbers.ixx. What's special for Visual Studio is that all module interface units need to have this ixx file ending. This can be different and will be different for other compilers. In the beginning, we declare that we are having a module here. We're writing export module and then the module name. So our module name is here numbers. And after that, we can have declarations and definitions. So first thing I do here is I define a macro or a magic constant 42. And one nice thing about modules is that this will only be visible within this module and not in any other code which might import this module. Then we have a function declaration. So we declare the function get magic number and we export it here. And this means that the function get magic number is exported and can be used by consumers of our module which import the module. So this is a function which is visible to the outside world of the module. And its definition is somewhere else, and we will see later why. Here we have another function which is called helper. As you can see, this does not have the export keyword. So this means it is not exported. This means it's only visible within the module, and any other code which tries to import our module cannot access it. So now let's look where the definition of get magic number is. Here we have a file numbers.cpp. And here in the beginning, we write module numbers. And with that, we tell the compiler and the build system that this file is part of our module, but it's not the module interface unit. It's part of the module and contains definitions, for example. And here it contains the definition of get magic number. And note also here, we don't need the export keyword here because we already did the export at the declaration in the module interface unit. We also have a third module called more numbers here, export module more numbers. Again, we have a magic constant or macro 21. And because we are in modules, it cannot lead to problems that this is also called magic and has another value because macros are not visible outside of a module. So this is not a problem. Also, we can see that we have again a function called helper. And this is also not a problem. It's again not an exported function, so it's not visible outside of the module, and it's not a problem if we have two functions with the same name and signature if they are not both exported.
Sorry, Hendrik. afisher92 in the comments has asked, does the .ixx name need to match whatever is in the export module?
I am not really sure. We can try it out later. Where was it?
Thanks. Just thought I'd bring that up.
Yeah. So here we have another function called get magic number with the same signature as the get magic number from the numbers module. And this is not a problem because since this function is not exported, it's only visible and usable within this module, and there are no collisions with the other get magic number functions from the numbers module, which is exported. And at the end, also, this module exports a function which is called more magic. And last but not least, we have a third module called printer.ixx. So here you can see the declaration of the module is not the first thing here we do in this file because here something special happens. And this printer module, I want to use code from which is not, let's say, self-contained. I need another library. I need the standard library. And what I need first here is the format library. So I installed fmtlib with VC package on my system, and I want to use it for printing because it's an excellent library. But being modules is a new feature. As a new feature, the FMT library is not modularized. So I need to somehow integrate its header here. And a possibility to integrate a header into a module is to include it in the so-called global module fragment. And what I can do there is I write the first line here, module. This indicates to the compiler that I want to access the global unnamed module. And in this global module fragment, only preprocessor directives are allowed. So I can do defines and includes and so on. And here I include FMT core. And what happens then is the compiler will look what entities from FMT core I use in my actual named module. This will be attached to the module, and the rest of the FMT core header will be discarded. After that comes my declaration of my module. And another thing I need for my code is a concepts header, and also the standard library of C++ is not modularized yet. And I could also include it here if I want to, but the standard library headers supports a feature which is called header units. And this means I can write import and then the name of the header. And you can imagine that this header is then treated as a pseudo module with all its contents exported. We will talk a little bit more about that in depth on the slides. And this is guaranteed to work for standard headers, and there are no guarantees for other headers that this works. So this include in the global module fragment will always work. This is only guaranteed to work for headers from the standard library. And I can import other modules. So we have the more numbers module. I need functions from that here in my code, so I import it. Then I have a function template print stuff, which I export. So notice that the export keyword has to be the first thing, even before template. Then comes my code. I use FMT in it. And I also use the more magic function from the more numbers module. And here's also something for you to notice. So you have seen there are no namespaces declared in my modules, which I showed you earlier. And C++ modules do not introduce implicit namespaces. So if I go to my more numbers module here, you see the more magic function. There's no namespace here, so this is attached to the global namespace. And C++ does not create a special namespace for the module for me. So this is just called with more magic. And afterwards, I want to show you a little bit special and confusing feature. So there is a way we have seen in the numbers module that I can separate the declaration and the definition of a function, for example, by putting that into two separate files, a module interface unit and a CPP file. I can also do something similar in just one file. So here I have the declaration of my add function. And here again, we see a module keyword followed by :private. And this tells the compiler that I want to access the private module fragment. This is used for separating declarations and definitions inside a single file. And this means I can change the implementation of my add function without affecting the importer of the module if I don't change the interface. And this can be used to accelerate incremental builds. And we will also talk more about that in depth later on. So when we talked here about the includes and the header units, I told you there's only a guarantee for the standard library that this works, but the FMT library is nice enough to work also with these header unit imports. So right now I will just compile the code to show you that it works. So it works, but you will not be able to see the output in my screen share, I guess. And now I will change the code. So I will comment that out and command that in. And this shows us that the FMT library behaves very nice and can also be imported as a header unit, although there's no guarantee for that to work. Switch back to original. So how does our main function look like? We import all three modules which we have defined, so numbers, more numbers, and printers. And the order of imports here does not matter. Notice that I still get here red highlighting. The IDE does not know what I'm doing, although it works. Hopefully this will be better in the next few releases of Visual Studio. And I can access all the functions which are exported in my modules. So get magic number from numbers, more magic from more numbers, and print stuff from printer. And as I told you before, I introduced no namespaces in these modules. So all these functions are attached to the global namespace, and we have to know where they are coming from if we do it this way. we can introduce namespaces. So I could, for example, here go to more magic and introduce the namespace. So, and I can think about how would I like to call my namespace, and maybe I want to call it like the module is called for clarity, and it sounds like a good design. So I could try to name it more numbers. And this actually works. So I have to go here, fix it here, and also fix it here. And now the code compiles and runs. And now it's a little bit more clear where my more magic function comes from. And maybe I have more functions here in it, which I all want to be exported. And if I want that, and I don't want to type export a couple of times, I can also export the whole namespace. And this means everything inside this namespace is implicitly exported. And if I save, everything will still compile. And the last thing I want to show you here in this coding session is that I can break my code or my program if I have two exported functions with the same name and signature. You may have noticed that in more numbers and in numbers.ixx, I have two functions which are called break my code. And maybe you want to guess what happens when I uncomment both. So now I have two exact same functions which are exported from two different modules, both in the global namespace. And I call it here in my main function and run the compiler and try to run my code. So maybe you want to guess whether this compiles or not. So who thinks this will compile? A few people are answering no. And at first I thought, oh, it will not compile as well. But if I compile it, it compiles and runs, and it tells me the program modules talk.exe exited with code 111. So I return 111 here from numbers. And an interesting thing can happen if I change the orders of imports here. If I import more numbers and then numbers and compile and run again, then my console tells me modules talk.exe exited with code 256. And this is a clear indication that something is very wrong here. And the problem is if we have this violation. So for example, two very same functions in the global namespace, or same namespace, same function, same signature, then this is a big, big problem. And the problem here is that our program is ill-formed, no diagnostic required. That means that the compiler is not required to stop and tell us that something is wrong. It's just a malformed program. And you have to know that, or otherwise you can shoot yourself in the foot really bad. And therefore introducing namespaces with modules is also a very good idea. Yeah. So, and now I will switch back to the slides to discuss the features more in detail. No. So now you should be able to see my slides again, hopefully. And then let's continue. So now in-depth discussion of features. And the first thing I want to discuss is module names. How can we call our modules? So we can use normal identifiers as module names, and we can join identifier via dots to create a module name. So we can create a module called name dot with dot dots, and this is a valid module name. But the dots do not carry any special meaning, as they sometimes do in other programming languages like Python. There are no submodules or a programmatically supported hierarchy of modules in C++. You can use these dots to communicate the illusion of a hierarchy, but there are no things like relative imports or import or submodules, which you might know from other languages like Python. So you can have like something like export module, I don't know, math.linear algebra. And this communicates some hierarchy, but the hierarchy is not supported by the language itself. And one interesting feature, which you've already seen in my code demo, is the module name can only be referred to in the module declaration or in import. This means that you can have namespaces or variables, classes, structs, and so on with the same name as your module. And this, as I've told you in the coding session, makes a lot of sense for namespaces to have a module name and then the same module name as a namespace. So many other languages like Python or Rust couple namespaces and modules, although these languages don't have the notion of a namespace explicitly. This means these languages use the module name to refer to a function inside of a module. So imagine we are writing some Python code and our Python code is inside a module called math. Then we go to another Python file, import math, and in our math module, there's a function dot product. Then we would write math dot product to access this function. And in C++, this is not the case. If we don't define a namespace inside of a module, all entities are attached to the global namespace. And as we have seen, this can lead to problems when two exported entities have the same name and signature in the global namespace, or in the same namespace also. Then our program is ill-formed, no diagnostic required. The compiler might stop and give us an error, but it's not required to, and Visual Studio does not. And it gives us just a malformed program in the end where things happen which are not allowed, like the order of imports do matter, or it returns garbage or explodes on us. We don't know. So good practice is introduce a namespace with the same name as your module to circumvent all these nasty problems. Now I want to talk a little bit about how modules can be structured in our code. It's called module units. We have seen in the live demo the module interface unit. This is the .ixx file in Visual Studio, which might be and will be called differently in other compilers. And this contains the export keyword and the module declaration. And it has to contain the declarations of possibly exported entities. And it can, if we want, also contain the definitions. So you can spot a module interface unit by the line export module and then the name of the module. There are module implementation units. They are called .cpp files in Visual Studio, and they can be used to separate the definitions of entities from its declarations in the module interface unit. And you can identify them by the fact that they start with just module and then the module name. And there is no export keyword in the declaration there. And the second thing is modules can be partitioned into parts. So there are module interface partitions and module implementation partitions. And we will talk about that on the next slide. So what are module partitions? It's a possibility to subdivide our modules. So I have an example here. I have a math.ixx file. I have export module math, so the name of our module is math. And then we have seen, then here's something which we haven't seen before. We have export import :modulo, and this tells the compiler, okay, there exists a module interface partition called modulo, which is imported here and then immediately exported again. And this is mandatory, so we have to import, export the partition, otherwise it's not a valid module partition. Then we have a separate file where we tell the compiler via export module, and then the module name colon the partition name, that we have a module partition here, and in it we can have things happening. So here we have a modulo function which is declared, defined, and exported. And what is really important here, this is only intended to structure our modules in a logical way. Again, these are not submodules. So if a user imports the math module, the user does not know that this partition does exist. So the user cannot import only modulo or can refer to modulo in any way. And it's just the mod function which is visible for the importer. So it has no effect on the user who imports the module, and it's only for us, the implementer of the modules, as a way to do logical structuring of our code. Because if we write a math module, this might be really, really big, containing a lot of functions, and we want to structure that in a logical way, for example, with partitions. And we've seen in the code in the live demo already the private module fragment, and it's the thing which can bite us here. It looks similar to this module interface or module partition. It started by module colon private in our code. It looks like a partition, but is not one. You don't see here import or export in the code. And here the idea is to separate declaration and definition of entities without having to rely on multiple files. So this must be in a single IXX file for Visual Studio, or in general in a single module interface unit. And the importer of our module only needs to know the non-private part of the module. So if we change the private module fragment in a way which does not affect the non-private part, this does not affect the importer. So if we leave the interface as it is, and we just, instead of x plus y, we would write x plus 3 times y, this would fulfill this requirement. And this can help the compiler to accelerate incremental builds. And the thing I don't like about this feature of modules is that it bears the risk of confusion with module partitions. Or at least I confused it with it in the beginning. Maybe you don't. I don't know. So now we have a couple of slides which feature some vocabulary that we need for understanding more about modules, and especially export, import, and the handling of headers. And we start here with the vocabulary. We need to distinguish what is part of our module and what is not. So we have the so-called module unit purview, which is everything from the module declaration to the end of the translation unit. So here we have a module mass. Here it's its declaration. Here somewhere down below will be the end of the translation unit. So this is part of the module unit purview. And if our module is split around in several files, the whole module purview will be the set of purviews from its module units. We need to talk a little bit about linkage as well when we talk about modules. So in C++, we already have internal and external linkage. These things are not new. So internal linkage means we have things which are inaccessible outside of the current translation unit. So for example, things inside anonymous namespaces, static things, and others. And we have external linkage, so things which are identical between translation units and can be possibly accessed from other translation units. And what is now new with the introduction of modules is module linkage. And an entity has module linkage if it does not have internal linkage, if it's not exported, and if it's attached to a named module. So if we think back to our code, if we have a function which is exported, this has external linkage. And if we have a function like the int helper function, which is not exported and it's not static or it's not inside an anonymous namespace, this means it has module linkage. And the last vocabulary I want to talk about with you is the global module. And in C++20, there can only be one module without a name or one unnamed module, and this is a global module. And if your code is not part of a named module, then it's automatically part of the global module. And there is a requirement. So there is one function which must be part of the global module, and this is the main function of our executable. And in general, all code is part of a module. It's either part of a named module or part of the global module. There's nothing else. And now we can talk about exports and imports in depth. Let's start with what can be exported. So we can export variables, classes, structs, functions, namespaces, template functions, classes, concepts, basically every entity in C++ you can think of. But these entities are not allowed to have internal linkage. So we cannot export static variables, static functions, or we cannot export anything within an anonymous namespace. Our export declarations must occur on namespace level. So we cannot export a member variable, and who would ever try that and what would that even mean? I don't know. We can export a whole namespace as I've shown already, and this implicitly exports everything in the namespace. And we can declare an export block, and in that export block, everything is implicitly exported then as well. So let's have a quick look at things which can be exported, which cannot be exported. So here we have an anonymous namespace. Inside of it, we have the int stuff function, which returns 0. We try to export it. This code will not compile because the stuff function has internal linkage and cannot be exported. Here we have my very accurate mypy variable. It's a static variable. We try to export it. The code will not compile. It has internal linkage. And then we have a struct point with int x and y members. And for some bizarre reason, I try to export the member variable x. And this is an export which is not on namespace level. So it will not compile, and it totally makes no sense anyway to try to do that. If we now look at things which can be exported, so as I already told you, basically every entity you can think of in C++ can be exported. We have seen functions. We can export a whole struct. We can export the variable, like here, the even more accurate pi, which is exactly 3. We can export a concept. We can export a template functions, but here we have to make sure that export is the first keyword which we use. And I already also mentioned implicit exports. So here we have the declaration of a namespace fun, and the namespace is exported. And this means that the function cool number, which lives inside this namespace, is explicitly exported and usable in another module if it imports this module. And this is the export block. So export and then curly braces, and everything inside of that is also implicitly exported. And these implicit exports are also a great way to shoot yourself in the foot. So if I try to put something in here or in here, which is not allowed to be exported, so something with internal linkage, so a static function, static variable, or if I put an anonymous namespace inside here or inside here, this will also not work. Then let's talk about imports. So one thing, import and export are not really keywords in C++20, so it's not forbidden to use import and also export as a name in your code. And this is something I would advise against. So if you have a struct or a function called import and you're also using modules and import something, this is also a great way to spark confusion among your developers, and it's ugly, so don't do it. And there are only a few rules on imports. So in a module unit, imports must happen before the first declaration, so basically as fast as possible. In a non-module unit, imports may occur after declarations. So if you are in your main.cpp, you can throw imports everywhere. Imports are only allowed at global scope. So if you try to import something inside of a namespace, this will not compile. A module cannot import itself. I would also not know what this would mean. And cyclic imports are not allowed. So here we can have again a look at an example. So here we are inside of a module unit. We have a declaration of the module here, so our math module. And we think that we need another module or code from another module in here. So the algorithms module, we import it, and this is totally okay. It's happening before any other declarations, and it's just another module. It might not work if there are cyclic dependencies. So if algorithms would also import math, for example, then we could have problems. But otherwise, this is totally fine. Now we try to import ourselves. This is not okay. This will not compile. Why would we try to do that? Next thing is we have a namespace fun. And we want to import here another module called fun stuff. And this is also not allowed. This is an import outside of the global scope and makes also not much sense. And here the last thing is something which might bite you. Here we have the first declaration. So we have our add function. And after we have written our add functions, we remember, oh, I need the more algorithms module. So I write my import here. But that's not allowed. This is an import after a declaration. This will also not compile. You just have to copy it here right under algorithms to make it work. Now, last big topic of this feature of this talk will be includes and modules, as also previously seen in the live coding session. And here we have an example of something which you shouldn't do. So we have here our module declaration. So here we are in the module purview, and here we include a big header.h. And includes in the module purview or the module unit purview are legal C++, but not a good idea. So the preprocessor will copy everything into the module, and everything from big header.h will be here, and it will get module linkage. And this is usually not what we want. Usually you want to use only parts of the header and not put everything in the module. And from an architectural point of view, you could now argue that the math module owns everything from big header.h. And if we would include this big header.h in several more modules in the same way, we would still compile the same stuff a couple of times and then throw things away as we've done before using modules, and we would have won nothing in terms of compilation times, for example. So what ways are around that? So we've already seen them, and you might remember them. The first way around that is the global module fragment. There is a possibility to access a global module before the declaration of a named module. So we have module semicolon in our code. This indicates that we want to access a global module. And inside this global module fragment, there are only preprocessor directives allowed. So for example, defines, includes. Everything in the global module fragment which is declared there and which is not used in the named module will be discarded. And only entities used in the named module will be attached to the named module with module linkage. So to paraphrase that, we will only get what we use from the header. And this is usually desired behavior. And this is useful for headers which rely on preprocessor state in the includer, So we could imagine that big header.h would behave differently if we define here, if we write here something like define windows or so, maybe big header.h then behaves differently, and this is a way to deal with that. And we can also do a little bit better with header units. We can import headers like modules in the module purview, but this does not convert them magically into modules. The code is treated as if it was a module with everything exported in it. And the difference to a normal module is that macros from the header, which is imported as a header unit, will be available for the importer. But defined statements in the importer have no effect on the imported header. So if our header relies on preprocessor state, this has a big chance of not working. And this is what I mean with it will not work on all headers. So if we rely on preprocessor state, this is a no-go. And there is a guarantee that it will work on headers from the standard library. And if it works for other headers, is purely implementation defined. And for Visual Studio and FMTlib, we had the luck that it works. But we might also be bitten here that it doesn't work. So again, how does it look like? So we have our module declaration. We are then inside the module purview, and then we import big header.h. This might be a better solution than including in the global module fragment, but again, we cannot know if it works without knowing what the header does exactly. So if it's our own header, or by trying it out. So I don't know everything which happens in FMTlib, so I have to try it out and see if it works. So what would be my advice for headers and modules? If you have your own header, so your own project which you are working on, then I would say start with trying to convert your own stuff into modules. This is the easiest way. Just invest the time, make modules out of your headers. If we have third-party libraries, things get tricky. So not many people already use modules in their libraries, and we usually don't know what happens inside third-party libraries, and we have no guarantees that header units will work. So we have to try them out as header units, and if they don't work, we can include them in the global module fragment, and this will work. And the thing which is nice for the standard library, there's a guarantee that the standard library will work as header units with the exceptions of the C headers. And this brings me to the conclusion of the talk. Let's talk in the end a little bit about advantages of modules. So modules help us with encapsulation and information hiding. We can decide explicitly what is exported and what is not. So this is a perfect implementation of modular programming. And from an architectural point of view, encapsulation and information hiding are very important, although this could already be achieved in C++. We get a better macro hygiene, so macros are not exported from modules, and this can help us solve some problems. And maybe the feature most people are interested in are faster compile times. So using modules or modularizing your whole code base might have a huge impact in compilation times for large projects. You have to try out for yourself. What are the disadvantages? So at the moment, we have a lack of compiler support, and this will, of course, improve over time since this is a C++20 feature. What is a little bit more scary is the lack or experimental status of build system support, and there we don't have the guarantee that every build system will pick up module support. And as I said earlier, the coupling of the C++ language feature to a build system implicitly is a scary thing. Now, we cannot have the guarantee that all people will update their build systems or meta build systems to support modules in the end. Of course, for the big things like CMake, this will surely come, but who knows what other people are using. We have no modularized standard library yet, but this will come in the future. And in the meantime, using the standard library as header units is okay. And of course, third-party libraries are not modularized yet. Some might be in the future, some might not. And not all of them will be usable as header units in all compilers. So this is clearly a disadvantage. So now you listen to me talking 55 minutes about modules. So maybe you want some advice on what you can do now. So my advice for Visual Studio users is use and learn modules with small projects. Yeah, can be a small project at work, can also be a hobby or side project you have, but it works now and you can use that on small projects to learn all the features. And for all others, I would advise wait for more compiler and build system support. The thing which for me disqualifies using modules in large production code bases right now is it requires code changes if you want to do it consistently and everywhere. But maybe the improved compile times might motivate you to try that out. Time will tell. And it's also not very good if you have like a cross-platform things going on because the compilers support different parts of the module feature set right now. And the lack of CMake support makes me really sad, to be honest. So if I've gotten to you and you want to now learn more about modules, so there are 2 great talks about modules from Meeting C++ 2 years ago. So Modules, the Beginner Guide from Daniela Engert and Modules Are Coming from Bryce Edelstein-Lelbach. These 2 talks are really, really great and they go more in depth also on theoretical aspects of modules. There's a great blog series called Understanding C++ Modules, which will teach you everything I've showed you right now, but in a written form. And as a Visual Studio user, you can have a look at these 2 blog posts here telling you about C++ 20 module supports in Visual Studio. Yeah, that brings me to the end. I will now look into the Q&A and try to answer as much questions as possible. But again, if you are not comfortable with writing your questions here, or if you're watching this on YouTube in 3 weeks, feel free to contact me on any social media I have with questions. And also, I would ask you to give me feedback to the talk as well. So I cannot know just talking to myself how good the talk is. If you think there's something bad about the talk, just write me a message and tell me how I can improve. If you liked something particularly about the talk, I would also be very happy if you write me that. So I want to improve myself. I want to improve the talk. I need feedback. Thank you. And I will now open up the Q&A tab. So I will scroll to the most top voted question. So the most top voted question is, where should template definitions go? Do they need to go into the IXX file? I think they need to go into the IXX file, but I'm not sure. My gut feeling says they need to go into the IXX file. I'm not really sure. We could try it out. The next question would be, is it possible to change existing projects to modules, or is it more suitable for new projects? So if you're starting a new project at C++ 20, try to use modules from the beginning. This is the easiest way. The thing is, in a large production code base, you could try using modules only here and there, but then you would not really benefit from it. Yeah, you have to handle all the legacy includes everywhere, and in some places you have imports, in some places you then have only includes. So you would need to invest a larger amount of time to get everything modularized, and only modularizing small parts of the code base might make not a lot of sense, but it depends on your code base. Do you know why it was decided not to automatically put imported modules into their own namespace? I don't really know why. There might be some reasons not to. I know that many other languages does it that way, but there might be reasons like backwards compatibility or so to not do it. But I'm not really sure. Maybe someone from the standards committee can answer that better than I can. So next questions, how do modules work cross-platform? So also an interesting question. So at the moment, they don't really work cross-platform because not all features have the same, and not all compilers have the same feature set for modules at the moment. And also different compilers and build systems are very opinionated on the file endings. So Visual Studio wants this .ixx ending. Build 2 build system doesn't like the IXX file ending. It wants CPP-M as a file ending for module interface units. GCC basically doesn't care how you name your module interface units. And for Clang, I don't really know. So in a way, modules here really hurt cross-platform efforts because you maybe have to write tooling to rename files, which I don't really like. And yeah, also what's interesting is that the serialization format, so the interfaces of the exported functions need to be serialized to disk. And this is also implementation defined by the compiler to how this is done. And this also might change. There's no exchange between these things possible. Can a CPP file belong to multiple module interfaces, module units? I would say no. Next question, can you say anything about how IXX files are found? Is there a search path as for includes? So if you use the functionality of Visual Studio to add them via this add functionality, then they are automatically added to the build definition. And there are some standard search paths, and you can also define your own search paths for modules in the Visual Studio project. Next question is, do you think modules will take over regular includes for new code? Gut feeling is not now, but maybe in C++23 or C++26, when we have also modularized standard library and better compiler and build system support, then it might take over. And I think the long-term goal is to get rid of the preprocessor altogether. But I'm not in the standards committee. Maybe someone else can answer that better than me. Are modules the end of the pimple idiom? It depends. Could be. I don't have a gut feeling there, but could be. What's the plan for modularized STL? So also, I don't really know, and at least not yet. Maybe in C++23, maybe later. And at the moment, I don't know the stage of the discussion. The next question is about shared object libraries. And therefore, again, I have to say, I don't really know, but we can talk about it later and I look it up. Next question, is it already faster than include files with the current implementation? How much faster? So I personally did not do any measurements, and from trying it out on, let's say, smaller or medium-sized things, I would say it is already faster, but I don't have any measurements. And I would think measuring this stuff could also be an interesting topic for like a 20 minutes talk, which could be done in the future. The next question is, with all of these new features, is the idea completely phase out include? And yeah, I would say here, yes, this might be this could be the long-term goal. Does all the old code written prior to modules go into the global module? Yes, everything which is not part of a named module is part of the global module. What's the known ongoing work for CMake to work with modules? I did some research there, and I don't find any roadmap for modules in CMake. But maybe this conference is so large, maybe someone who develops on CMake is here and can answer that. When would you use a global module apart from the main function? It seems like a better idea to use named modules. Yes, if we write modularized code from scratch, we would only use the global module for the main function and put everything else in named modules. But for, let's say, it legacy code, which we are modularizing step by step, then the use of the global module is that your code, which you haven't modularized yet, lives there. If I have a library, can I make it usable as a module while still being usable as a traditional include? Ooh, good question. I haven't thought about that much, but I think if you have these export module and so on keywords in it, it might be hard to make it also usable as a traditional include. Here's again a question about how that can be faster if the build system needs to look at the CPP files. Well, it does need to do it once and only on changes. So there's a possibility to make it faster. And I personally do not have benchmarks, but benchmarks could be something for another talk. Questions. When I say Visual Studio users try modules, everyone else wait. Do you mean projects built and managed entirely in Visual Studio only? Yeah, I mean basically that. If you have a project which is Visual Studio, MS Build, Windows only, try that out. CMake does not work, so I think we cannot use CMake projects which generate VS solutions with modules yet. GCC trunk supports a partial feature set of modules. The question is, does GCC support modules? The answer is partially in trunk. Another question is, how do you deal with two modules exporting the same function in the global namespace? Yeah, this was part of the talk already. This is then your program is ill-formed, no diagnostic required, basically. From your example, could we have accessed the function using numbers, : function name, or more numbers, : function name without defining namespaces? No, we have to define namespaces explicitly here. And last question I see at the moment, are non-exported functions at variables work similar as static entities? EA and no exported symbol at all. Well, they have module linkage. This is a little bit different than internal linkage, but from an outside world view, they are very similar. So there are no questions left in the Q&A. I will now have to look in the chat. There's something else, but otherwise, I think we are finished here. I will wait. We still have, I guess, if the track host is here, I guess we still have 20 minutes left. So I would leave.
Yeah, you've got some time, but it's if you're happy, if that's all the questions, that was quite a lot of questions. So I think there was plenty of time there for people to ask any extra. I think that's probably it.
Yeah, I will wait a couple of minutes if any more questions come pouring in. And I see some thank yous in the chat. Yeah, thank you for watching me.
I'd just say that if you do want to carry on, you can carry on the chat in Remo or on the track discussion channel in Discord. So it doesn't have to be here.
No.
I mean, I'm happy to sit and just let people have a chat. But if that's it for everyone, then that's fantastic.
Yeah, since I see the thank yous pouring through here, I think we are done. There's one question left. If I have any thoughts on Deckel spec? No, I have no thoughts on Deckel spec. I'm sorry. And yeah, thank you for watching me. And again, as I said, I will hang around in Remo till the end of the conference today. And I will also be the next days in Remo. You can come to my table, ask me questions, or talk to me if you want. And again, I would also value feedback a lot. So if you like the talk in general, or have something in particular which you liked or disliked, then please tell me, because I might be doing this again at another conference maybe, or at a meetup, and I want to get better basically.